Hello friends, welcome back to our series of sessions. In the last videos, we try to understand how the law program is working and then how is the management education, undergrad management education is working, right? So today we'll be focusing much on the test taking strategies, or rather we are talking about the preparation techniques here, okay? Let's stay tuned, watch the video carefully, let's see. If you are looking at an undergrad law program, we have various exams. Number one, we are talking about the Clat, Common Law Admission Test. Other than Clat, you also have IELT exam that is for NLU Delhi. You will be having for symbiosis SLAT exam. You also have a Narsi Munji exam. You have a Jindal Global Law University LSAT exam. We also have MHCET law exam, that is Maharashtra Common Entrance Test. We have a Christ University exam, various set of exams. As we discussed in the last video, across this exam, the testing areas are quantitative aptitude, verbal ability, GK, then we are talking about legal reasoning, then logical reasoning, right? And you also know not every exam is testing this one here. You know that one very well. For example, if you look at a Jindal LSAT exam, you don't have a QA there, you don't have a GK there, you don't have a legal there. You only have a verbal ability, logical reasoning part one, logical reasoning part two. You have only those sections here. So the pattern of exams is different here. Few exams, they don't have few of these components here. Today, we are trying to understand how do we handle the problems of this kind. Let's see, today we are trying to understand first the quantitative aptitude part. The kind of questions we are getting in math, I divide them into four categories basically. Category one, problems based on elimination of options. Category two, basics and applications. Category 3, problems based on assumptions. Category 4, problems based on the pattern methods. That is, you apply different patterns to solve the questions. What are these techniques? We will try to understand one by one. Let's see the first one, elimination of options. A couple of years back, in any one of the competitive exams, like you're talking about law entrance exam, or for students who are preparing for Ipmat and then BBA entrance exams here, we used to have testing which is very robust. They used to have a lot of questions on the calculation techniques, on the simplification techniques here. You know, there are a lot of changes in the exam patterns nowadays. As you know, a couple of exams went online. Wherever TCS is conducting exams like a CAT, they also provided an online calculator here. When there's an online calculator, you don't have to get into really a tough calculations. You don't have to learn what is 179 into 178. You don't have that requirement here. But a CLAT exam still being a paper pencil test, at few parts you may have to go for some little calculations here. Though the number of questions we have in QA section, you don't have something called a QA, rather you have a section called a QT, quantitative techniques. There are 15 questions here out of 150, right? So in these 15 questions, there will be 1-2 questions wherein you have to get into calculation. That to a minor calculation here, you don't have to get into tough calculations. एक जमाना पे we used to focus much on taking the classes of speed math techniques. We used to teach a lot of shortcut techniques of speed math. Though it is there, but still you don't require that lengthy calculations learning right now, considering the present pattern of the paper here. So now we will teach you various other methods. In this calculation part, we recommend students to go for something called a digital sum calculations. I'm saying we will recommend students to go for a digital sum calculations here. What are digital sums? For example, I gave you a number like a 3, 2, 5, 7, 8, 9, 1, 4, 3, 5, 2, 6. I asked the student to find the sum of the digits of the number. 3 plus 2 is 5, 5 plus 5 is 10, 17, 25, 34 plus 1, 35. This is 39, 42, 47, 49, and 6 you are talking about 55. Sum of the digits is 55. In 55, if I add 5 plus 5, 10. In 10, 1 plus 0 is going to be 1. The final single digit 1, that's called the digital sum of the number. That's called the digital sum of the number. So what do you mean by digital sum? You keep adding the digits till the time you get a single digit number. The final single digit is called the digital sum of the number here. Okay. For example, at home, your dad purchased a vehicle. Your vehicle has got a registration. Okay. Your vehicle has got a registration number of, let's say, 7925. Most of the families, they're crazy about lucky numbers. You all know. How will you find the lucky number of your vehicle? 7 plus 9 is 16. 16 plus 2 is 18. 18 plus 5 is 23. In 23, 2 plus 3 is 5. That's a lucky number, right? Mathematical language is digital sum. For example, I have a number 89, 8 plus 9, 17. In 17, 1 plus 7 is 8. For example, I have a number 93, 9 plus 3 is 12. In 12, 1 plus 2 is 3. These are all the digital sums, right? When I'm sitting in an aptitude class, I should ensure that I focus heavily on the board. In case of 89, for 9, I'm adding 8, I got 8. In case of 93, for 9, I'm adding 3, I got 3. My understanding is for 9, if I add any number, I will get the same number back. All of you agree? For example, if I take a number 92, 9 plus 2 is 11. In 11, 1 plus 1 is 2. I'm getting the same number back. So in the process of finding a digital sum, wherever I can make a sum of 9, I can eliminate the sum 9. The left out number sum is going to be the digital sum, right? So here for my vehicle registration, 9 is waste, 7 plus 2 is 9 waste, the left out number is 5. That is my digital sum, right? For the big number, 7 plus 2 is waste, 9 waste, 8 plus 1 is waste, 3 plus 6 is waste, 5 plus 4 is waste. The numbers left are this 5, this 3, this 2. 5 plus 3, 8, 8 plus 2 is 10. In 10, 1 plus 0 is 1. That is the digital sum of the number. So to find digital sum, I don't have to do a donkey's job. I can make a sum 9. I will eliminate the sum. The left out number sum is going to be digital sum. Agreed? Now, where do you apply this concept? For example, there is a number 12, there is a number 13. I'm supposed to add these two numbers. The addition is 25. I don't know additions. 12 digital sum 1 plus 2, 3. 13 digital sum 1 plus 3, 4. 3 plus 4 is 7. 25, 2 plus 5 is 7. Both are same only. So digital sum holds good for plus, automatically holds good for minus because it's a reverse, right? For example, I have a number 12, I have a number 13. Someone asked me to multiply. I don't know multiplication. The product is 156, right? 12 digital sum is 3, 13 digital sum is 4, 3 fours are 12, digital sum is 3, 1 plus 2, 3. Right hand side 1 plus 5 plus 6, 6 plus 6, 12. Digital sum is 1 plus 2, 3. Same only. That is digital sum holds good for into, automatically holds good for divided as well. So henceforth for all mathematical operations, what are the operations? Plus, minus, into, divided by. I use a single concept. The single concept is called the digital sum. Is it okay? So digital sum is a single concept where you can solve all these questions here. So wherever you find calculations, henceforth you apply this method. Okay. Now on the basis of learning what we had, we will solve few questions right now. I saw a problem somewhere. 174 into 175 equal to what? If I look at the option choice, 30450, 40310, 40350, 30450. These are the options. 30450 already given, na 32450. So how do I solve the problem? Let's see. 174, 1 plus 7 is 8, 8 plus 4 is 12, digital sum 3. When 174 is 3, the next number 175 has to be 4. 3 4s are 12, 1 plus 2 is 3. So the digital sum of the given question is going to be 3. All of you okay? At this point of time, you are saying the digital sum of the given question is going to be 3 here. So when the question has got 3, option choice must also be having 3. First option, 4 plus 5 waste. Digital sum is 3. Very much possible. 4 plus 3, 7. 7 plus 1 is 8. This is 8. This cannot be the answer. 4 plus 5 is 3. This is also possible. 3 plus 2, 5. 5 plus 4, 9 is 5. This is not possible. I have only two options left. My answer can be either A or my answer can be either C. So I have two options lying between A and C. But my answer is a unique answer. A multiplication cannot have two different answers, right? My numbers 174 and 175, if I assume these numbers are close to 200, right? If I assume that these numbers are close to 200, the product would have been 40,000. When the numbers are less than 200, the product is less than 40,000. So anything above 40,000 will not work. Below 40,000 will work. That's why option is A. My answer has to be 30450. This is how I can use digital sums in multiplications and then additions, right? Absolutely. We will see the next question. Which of the following is a perfect square? There is a question, which of the following is a perfect square? I have a couple of options. A, B, C, and D. Option A. One five three two seven nine six, 1522756, 1532796, 786, 1522746. If you can recollect, in our childhood, we solved these problems here, how to find a perfect squares, right? How we used to solve this question? We used to separate two digits from the ending, and then we used to solve the problem. It's a very complicated procedure. I don't have that much time. I look at the other way. 1 squared 1, 2 squared 4, 3 squared 9, 4 squared 16, 7, 5 squared 25, 7, 6 squared 36, 9, 7 squared 49, 9 waste 4, 8 squared 64, 1, 9 squared 81, 9. If I can understand 1497 7941, again we are talking about a number 9. So if a number is a perfect square, inka digital sum has to be 1479. If a number is a perfect square, inka digital sum has to be 1479. Is it okay? Is it clear? I'll repeat again. We are talking about if a number is a perfect square, the digital sum of the number has to be 1479. It cannot be any other number. The same numbers are repeating every time. Now I look at the problem, given problem here. What is the given problem? The option choice are 1532, blah, blah, blah. Let me work on this question. First option, 9 waste, 7 plus 2, 9 waste, 6 plus 3, 9 waste, detail sum is 1. 7 plus 2, 9 waste, 6 plus 2 plus 1, 9 waste, 5 plus 5, 10, detail sum is 1. 7 plus 2 waste, 6 plus 3 waste, 8 plus 1 waste, 5. Next, 7 plus 2 waste, 5 plus 4 waste, 6 plus 2 plus 1, 9. 1497. 1497. You have eligibility only for B and D options. So between B and D, you have only one answer, which can be a perfect square here, right? But for this question, they have given only one answer. You don't have two answers. I need to eliminate one option between B and D. Your option B is 1522756. Your option D is 1522746. I just do some groundwork. If the square of a number is ending with 6, then the parent number has to end with either 4 or 6, right? Take 4 squared, 16, 6 squared, 36, 14 squared, 196, 16 squared, 256. All these perfect squares are ending with 6 only. 6 का पहले नंबर 1 है, 6 का पहले नंबर 3 है, पहले नंबर 9 है, पहले नंबर 5 है. 1, 3, 9, 5. These are the numbers before 6. If you can just understand what is the property of these numbers 1, 3, 5, 9. Please don't say prime number. 1 is neither prime nor composite. 9 is not a prime number here. So the logic is not prime number. The logic is they're all odd numbers. So if a perfect square ends with a 6, the number which is before 6 has to be an odd number. In the last option choice, they have given even. That's not possible. That's why my answer is B. This is the advantage of applying digital sums. So my friends who are preparing for law Ipmat exams, please understand that these are the basics of digital sums. And at many points where all digits are given, whether you say it's a multiplication, addition, subtraction, anything here, digital sums will always hold good. Am I clear? Can I go ahead with the next question? Yes. For example, they gave me a question AB, BA, and CD are two-digit numbers. They also said that AB into CD equal to 1073, BA into CD equal to 2117. They asked me what is AB plus CD value. I'll repeat the whole question again. AB, BA, and CD. They are two-digit numbers, okay? AB into CD equal to 1073. BA into CD equal to 2117. They ask you what is AB plus CD value. They gave a couple of option choice. 63, 65, 66, 68. If I have to solve this question, the moment I give this question to a student, immediately they will see AB into CD, BA into CD. In both the cases, CD is a common factor. That's why between 1073 and then 2117, I'll identify for the common factors, then I'll solve the problem. A बहुत lengthy procedure. मेरे पास इतना time तो है ही नहीं. You don't have that much time here. You need to have an alternate technique in which we can solve the problem. There is an even number. When I say even number, don't make it as a rule. You imagine in your mind 2. There is another even number, 4. 2 4s are 8. Result is an even number. There is an even number, there is an odd number. 2 into 1, 2, which is an even number. Odd number 1, odd number 3. 1 into 3, 3, which is odd number. So if product of two numbers is odd, then both the numbers are going to be odd numbers. Is this okay? So if product of two numbers is odd, then both the numbers are going to be odd here. In this case, 1073 is an odd number, then both AB and CD have to be odd number. That is, they both are like 1 into 3, they both are like 3 into 5. If they both are odd numbers, 1 into 3 or 3 into 5, their sum 1 plus 3 is an even, their sum 3 plus 5 is 8 is an even, right? So my answer of AB plus CD has to be even, cannot be odd. I'll eliminate these two. What are the options I am left with? 66, 68. Now between these two options, I need to hunt for a single answer, right? Let's work on that. In AB, the number is ending with B. In CD, the number is ending with D. The product is ending with 3. In mathematics, the digits are always ending with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There is a number ending with 0. The whole product ends with 0. 1 into 3, the product ends with 3. If a number is ending with 2, the whole product is ending with an even number, 2, 4, 6, 8. If 5 is an odd number, 5 ones are 5, ends with 5, 5 twos are 10, ends with 0. Always 5 properties, with odd it will give you 5, with even it will give you 0. So 5 will not work. So the only opportunity for you is 1 into 3 ends with 3, 9 sevens are 63 ends with 3. You mean to say your AB and CD are numbers which are ending with either 1 3 or 9 7. So now if I have to understand, if they are ending with 1 and 3, sum ends with 4. If they are ending with 9 and 7, sum ends with 6. So your AB plus CD sum has to end with either 4 or 6. 8 will never come. That's why my answer is 66. My answer AB plus CD has to be 66. 8 doesn't have an opportunity here. This is how you solve the questions of elimination of options. So my friends, if you can understand, Elimination of options largely works when you have all digits present. You are focusing on the digital sums, even cases, odd cases, prime cases, various set of cases to solve the problems of this kind. Is it okay? We'll go to the next one. Basics and applications. How do we solve those questions here? While we are solving the questions, you must always be strong with the basics, right? For example, someone asked me what is the divisibility rule of 2. The number must be ending with 0, 2, 4, 6, 8. Then it is divisible by 2. You all know that. I want to divide a number by 3. What is the divisibility rule? Sum of the digits of the number should be a multiple of 3. That is, it can be 3, 6, 9, 12, blah, blah, blah. I want to divide a number by 4. What is the divisibility rule? Last 2 digits have to be divisible by 4. I want to divide a number by 5. What is the divisibility rule? The last 8 must be either 0 or 5. I want to divide a number by 6. The number must be divisible by both 2 into 3. Keep 7 separately. In the topic of numbers we will learn. I want to divide a number by 8. The last 3 digits of the number should be divisible by 8. I want to divide a number by 9. The divisibility rule is sum of the digits of the number should be a multiple of 9. It can be 9, 18, 27 kind of stuff. I want to divide a number by 12. 12 can be written as 2 into 6. 12 can be written as 3 into 4. Between these two, what is the divisibility rule? I will say it is 2 into 6. Assume. If I say 12 divisibility rule is 2 into 6, it's a blunder. You know why? You take a number 18. 18 is divisible by 2. 18 is divisible by 6. Is 18 divisible by 12? No, it is not divisible by 12. So divisibility rule of the number 12 cannot be 2 into 6. The only alternative we have is 3 into 4. That's why 3 into 4 is the divisibility rule. If I am preparing for some chota mota exam, this kind of approach is okay. But when I'm going for certain prestigious exam, I need to understand why 2 into 6 is not working. Why 3 into 4 is working here, right? Do not buy hard the things. I have to do a deep dive. What kind of a deep dive we are talking about? Let's put it this way. In case of 2 into 6, 2 into 6 is again 3 into 2, right? That is, if I am writing it in the form of A into B, in both the cases, 2 is a common factor. If you want to find the divisibility rule of a number n as A into B, you should ensure that A and B don't have common factors. A and B don't have common factors. In case of 2 into 6, this is a common factor. But in case of 3 into 4, 1 into 3, 4 is 1 into 2 into 2. Other than 1, do you find any common factors? No. That's why you don't have any common factors. That's why the divisibility rule is going to be 3 into 4. So henceforth, to define any divisibility rule, write it as A into B, ensure that A and B don't have common factors. Got it? Now we will understand the question. There is a question given right now. The question is all about find the least number of digits in the number divisible by 225 having all digits ones and zeros. I'll repeat my statement again. I want to divide a number by 225. The number must be having the least number of digits here, okay? The number must be having only ones and zeros. Then find the least number of digits in the number. First, I need to identify the 225 divisibility rule. I can say 5 into 45. I can take another 5. 25 into 9. Take a 3. 75 into 3. I can also say this is 15 into 15. These are the divisibility rules. So for 225, A into B forms are, these are the cases available. But we said they should not be having any common factors. 545 will not work. 75 3 will not work. 15 15 will not work. What are the only case available? 25 into 9. So if a number is to be divisible by 225, the number must be divisible by both 25 into 9. Agreed? First, let me finish the case of 25. If a number is to be divisible by 25, the last two digits are 0, 0, 25, 50, 75. Right? Any digits before this? 100, 125, 150, 175, 200, 225, 250, 275. All are divisible. So if a number is to be divisible by 225, the number must be having must be divisible by both 25 into 9. But in this question, they said only ones and zeros are allowed. 25 not allowed, 50 not allowed, 75 not allowed, 25 case is done. The other case is 9. How do you find the divisibility rule of 9? Sum of the digits should be a multiple of 9. If I write 9, 900 sum of the digits is 9. But can I write 9? No, because the number must be having only ones and zeros. Rather, you do one thing. 1, 2, 3, 4, 5, 6, 7, 8, 9. What is 9 ones sum? 9. 2 zeros are there divided by 25. The whole number is divided by 225. The least number of digits in the number is 11. These are the best practices you can do in math. So my friends, when you are talking about basics and application, it is highly recommended whether you are preparing for a CUET exam or you are preparing for a law entrance exam or you are talking about an Ipmat exam here. Basics you always need to be strong. Then the next step will be where will I be applying my basics? Is it okay? That's how the preparation strategy works. See, we will do the next two models that you are talking about assumptions method and then pattern methods in the subsequent sessions. Till then, stay tuned, subscribe the channel, watch the things videos carefully.